All right, everybody, welcome to the video here for lesson number 4 on equations of the perpendicular bisector. So in lesson number 4, what we're going to do is we're going to kind of use what we did in the previous 3 lessons and kind of combine it all together to do a couple of different types of questions. But before we can do that, we have to look back at 2 vocabulary words that we should remember from previous units. The first one is perpendicular. So what does perpendicular mean? So perpendicular means to us that 2 lines intersect at 90 degrees. Now, because we're in the chapter about coordinate geometry, what this means to us in coordinate geometry is these have negative reciprocals of slope, right? So when we're looking at this in coordinate geometry, yes, the 2 lines are perpendicular. That means that they intersect at a 90-degree angle, but in coordinate geometry, we're also then adding the extra piece of they create negative reciprocal slopes. That's what we learned in the last couple lessons. A segment bisector, right, is a line that divides a segment in half. Now again, that's great, but let's talk about coordinate geometry here. If I take a segment and cut it in half, that's me finding the midpoint. So we're going to take these 2 things and we're going to put them together. All right, and the best way for us to really do this is to really just look at the process, right? The process is pretty straightforward. So in example 1, I have the process outlined for you here on the left. The process is first find the midpoint, then determine the slope, then determine the perpendicular slope, and then write an equation of a line. It's basically what we just did in the last couple lessons. We're just putting it all together. So let's take a look at this first question. So it says segment AB has coordinates of 3, 8 and negative 5, 4. So let's graph those. And if we go through and connect our points here, we have this line segment. So the first job that we have is to find the midpoint. So to find the midpoint, we can do one of 2 things. We can either do it algebraically, right? We could say the x value of the midpoint is equal to half of the sum of the x values. And we can figure out that the x coordinate of the midpoint is -1. But since I have graph paper, I could just say, all right, I'm going over 8. Well, I only want to go over half of that, so I'll go over 4 and then go up, and there I am at my point. Or again, if you want to use your algebra, right, you can totally do the algebra, right? It doesn't matter either way. As long as you're getting the right answer, I honestly don't care how you get it. The nice thing is if this was on a test or a quiz, you could always use graph paper, right? So now I know the coordinate of the midpoint. So the midpoint, we'll call that MP, is -1, 6. Again, whether you got it graphically or algebraically, your choice. And then it says to determine the slope of the segment. The slope of the segment is the rise over the run. So if I look, all of these points are right on this line if I graphed it nicely with a straight edge. So I could see the slope is up 1 to the right 2. That's how I would get from each point to the next. So the slope of this line is 1 over 2. Remember, it's rise over run. If we didn't have graph paper and I was just given the points, I could always use the slope equation as well. So if the slope of the line is 1/2, that means the perpendicular slope is -2. So here's what I want to do. Now that I know the midpoint, and I know the slope, and I know the perpendicular slope, I want to write an equation of a line that passes through this point, -1, 6, with a slope of -2. Basically exactly what we did in lesson 2. So I'd say y minus y1 equals m times x minus x1. I like to use this form better, right? Because this form is going to be used when we have slope and we have a point. I don't know what the y-intercept is, so I don't want to use y equals mx plus b here. So if I plug in what I know, the y value is 6, the m value is -2, and the x value is -1, double negative there. So let's clean up that double negative. So I have y minus 6 equals -2 times x plus 1. Totally leave it like that. Or if I want to, I could distribute. So we'll get -2x minus 2, add 6, and we have the equation of line as y equals -2x plus 4. So if I was to graph that, so here's plus 4, 1, 2, 3, 4, down 2 to the right 1. This line is going to pass through that midpoint that we found, and if you look, it's perpendicular to the original segment too. So this line that we just found is what we call the perpendicular bisector of segment AB. It's cutting segment AB in half at a 90-degree angle. That's all we're trying to do today. This process is going to be repeated for the next 4 problems. It's the same process every single time. So if you're one of those people that wants to memorize a process, it's a 4-step process. Find the midpoint, determine the slope, determine the perpendicular slope, write an equation of a line. So let's try another one. So here we have a line segment that has been graphed for us. So our first job is to find the midpoint. So it looks like I'm going to the right 1, 2, 3, 4, 5, 6. So cut that in half. So go to the right 1, 2, 3, and go down to your line. Here I am. That's my midpoint. So we could say the midpoint of this segment, without having to do really much math, is 1, 6. I just had to do some counting. Now the slope of this line, if I go to the right 1, down 1, to the right 1, down 1, I see that the slope of this line is -1. I'm not interested in the slope of this line. I'm interested in a perpendicular line. So the perpendicular slope would just be +1. Remember, if you take the reciprocal of 1, it's still 1. So now I want to write an equation of a line that passes through 1, 6, but has a slope of 1. So I'm going to plug in the point 1, 6 and the slope of 1 to my new fun equation that we've been using. Distribute the 1. 1 times anything is itself. And add the 6. So we get y is equal to x plus 5. Go ahead and graph that. 1, 2, 3, 4, 5. Up 1 over 1. That's my slope. If you don't know how to do this without a graphing calculator, use a graphing calculator. It's up to you. But you should be able to graph a line. Look, it's perpendicular. It looks like it's passed through the middle. I think we did our job. Now, not all of these questions are going to provide you a nice piece of graph paper to count boxes and find the midpoint easily and find the slope easily. Some of them are going to look more like number 3. So number 3 gives us a line segment that connects point N to point Y. And says determine and state the equation of the perpendicular bisector. Before we can find the equation of the perpendicular bisector, I first have to find the midpoint. To do that, I have to do the algebra. I don't have graph paper. I can't count boxes here. So the x value of the midpoint is going to be half of the sum of the x values, so -11 plus 5. So the x value of the midpoint is going to be -3 if you type that in your calculator. The y value of the midpoint is going to be half of the sum of the y values, which is going to give you +1. So the midpoint is -3, 1. So we want to draw a line or create an equation of a line that passes through that point. But I want to make sure that I have a slope that's perpendicular to the slope of this original segment. So the first thing I have to do that is figure out, well, what is the slope of this segment? Luckily for us, we know how to find slope. Slope is subtract the y values and subtract the x values. We can label this as x1, y1, x2, y2. You did this already. You did this in algebra. You did this in 8th grade. This is not new. Okay? If you don't believe me, look back at your notes from last year. So if we do this, we can plug in my y2 and y1. So I could say negative 5 minus 7 divided by 5 minus negative 11. I'm subtracting the y values and subtracting the x values. If I do that, I get negative 3 over 4. Now that's the slope of the segment. I want a perpendicular line to that segment. So I want to find the perpendicular slope. Well, if the slope is negative 3/4, the perpendicular slope is positive 4/3. So now here's my job. I need to create an equation of a line that passes through this point and has this slope. So I'm going to say y minus 1 equals 4/3 x minus negative 3. Just plugging into this new equation. So I could say y minus 1 equals 4/3 of x plus 3. I'll just clean that double negative up. Totally fine if I leave it like that, or I could distribute. So I'd get y minus 1 is equal to 4/3 x plus 4. 4/3 times 3 is just 4. Add 1 to both sides, and we get y equals 4/3 x plus 5. There's my equation that they're looking for. All right, let's keep going. Number 4 is going to look very different, but it's asking us to do the same thing. So it says an isosceles triangle CAB has the coordinates of CA and B such that segments CA and CB are congruent, meaning it's isosceles. And it says determine the equation of a line that contains the altitude of CAB that passes through point C. So first thing I want to do is graph this. So I have negative 1, positive 1. I have negative 8, negative 2. And I have negative 4, negative 6. C, A, B. Use your straight edge here and graph your lines. Let me just graph my straight edge. So we have a straight edge. Okay. So we want to draw an altitude. Altitude is a fancy word for a perpendicular line. Now, a perpendicular line from point C to come down to here is going to also have to pass through the midpoint of AB. Why do I know that? Because these two segments are congruent. In an isosceles triangle, any isosceles triangle, if you draw the altitude in, it's going to bisect the base. It's going to make these two pieces on the bottom the same size. So segment AB gets cut in half at this point here. So the midpoint of AB is at the coordinate negative 6, negative 4. So essentially, if I find the perpendicular bisector of AB, I'm going to find the equation of this altitude. Now, if you look, the slope of AB is negative 1, meaning the perpendicular slope is positive 1. So I want to draw a line, right, that's going to have a slope of positive 1 that passes through this point here. So I'd go up 1 over 1, and I want to draw this line in before I do any of the algebra to make sure that it actually passes through C, which it does. So this this diagonally drawn line here is going to be perpendicular here, making it an altitude, and it passes through C here, satisfying the restriction they asked me about. So now I just want to write an equation of a line. So I have a point, I have a slope, so I can say y minus negative 4 is equal to 1 times x minus negative 6. Clean up those double negatives by making them pluses. And we can solve from there. All right, I'm just going to go through this quickly because we've done this so many times now over the last few lessons. It's just algebra. Distribute, subtract, and we get our answer, x plus 2. All right, so let's talk example 5. Example 5 is a little tricky. It's actually one of the easier questions, but it's tricky because it's not a regular type of line. It's either a vertical or a horizontal line. Notice these two numbers are the same. So we still want to draw a perpendicular bisector, but now we're talking about 2 points that share the same y value. So if I was to draw this segment, one point would be like 3, -6. The other point would be on the same horizontal line because it has the same y value. So this line that we're cutting in half is going to have to be cut in half by a vertical line. Now, one of the things that we remember, I'm hoping, is A and B, if they're different numbers, if x equals A, that always becomes a vertical line. If y equals b, that always becomes a horizontal line. Okay, that's something you should have learned in Algebra 1. So the job that we really have here isn't really to do a bunch of the math we've been talking about. It's really just figure out what the midpoint is. So what's the midpoint between 3, -6 and 7, -6? Well, I know it's going to have the same y coordinate because it's got to be on this same horizontal line. So really all I'm asking is, what's the number between 3 and 7? Well, that number is 5. So I want to draw a line or come up with an equation of a line that's going to pass through the point 5, -6 and is vertical. Well, that's going to be x equals 5. That's it. You don't have to use the new formula because it's a vertical line. All right, this is the point of the lesson where you should pause it or come back to it after you've tried your homework questions. Right, the homework questions, there's just a couple of them. The second one is actually multiple choice. It was a Regents question, so we could talk about that when we get there. But again, I want you to pause the video, try the homework on your own, come back to it. Don't just blow through this whole thing all one shot, okay? So hopefully I'll see you soon. All right, so welcome back to the video here. We're about to start the homework assignment. So in the homework assignment, the first question asks us to find the perpendicular bisector of this segment. So to do that, our first job is to find the midpoint. So if I look, the 2 points, if you go across here, you're going to go across 10. So if you go in half, that's just 5, meaning the middle is 0, 0. Nice, we can count boxes here. So the midpoint of this segment is 0, 0. The slope of this segment, to get from one point to the next, if you look at all these points, I'm going to go up 1 to the right 2. So the slope of this segment is 1/2, meaning the perpendicular slope is -2. Now, if I want to write an equation of a line here, I need to use this point, 0, 0, and this slope of -2. So I'd say y minus 0 equals -2 times x also minus 0. Subtracting nothing is just leaving you the variable. So I have y equals -2x minus nothing. There's my answer. I distributed the -2 to 0, which makes 0. So all I'm left with there is -2x. Now, if you were to actually graph the line y equals -2x, put it in your calculator, it's going to give you this set of dots, which make a nice perpendicular bisector happen. Number 2 is multiple choice. This was actually a Regents question. So it says segment CD is the perpendicular bisector of AB. So that sentence alone is telling you what's being bisected. AB is being bisected. So if we make the point AB, this line is being bisected at point E, meaning this segment and this segment are definitely the same size. Now it says, which pair of segments does not have to be congruent? I know AE and EB are congruent, so I'm going to find that one and cross that one off. I know those are the same size. Now the segment CD is what's doing the bisecting. So if I make C here and D way down here, this segment that I just drew in is bisecting the line. Notice I exaggerated the fact that C is closer to E than D is on purpose. Now I'm going to draw in some lines here. I'll use different colors so it doesn't confuse you, I hope. I'm going to draw a line from A to C and from C to B. Wouldn't those two lines be the same size? They're the same distance from C, so that would make that choice B wrong. No matter where I put point C, even if I drew it differently, if I made it so that point C was way up here, it still would have been the same length from A to B. All right, let's try another set of dotted lines here. So if I draw another set of dotted lines here from A to D, that distance from A to D and from B to D has to be the same as well. If not, it wouldn't be perpendicular, right? If AD was longer, that would make D be over here. It would not be perpendicular. So choice A also doesn't work. The only set of segments that don't have to be the same size are segment CE and segment DE. Because that's just perpendicular and bisecting, how and where it bisects doesn't really matter on that segment. So the answer here is choice D. All right, let's try another one. So the last question gives us a point here of point A, -6, +1, and point B, which is 2, 5. If you connect your points, hopefully with a straight edge, you have A and B. And our first job, if we want to find the perpendicular bisector, is figure out where does it bisect. It bisects at -2, 3. That's the midpoint. I'm getting that just by counting boxes. I'm going from point A to point B. I'm going across 8 boxes, so just cut that in half at 4 and go up to your line. Now the slope of this line is up 1 to the right 2. I'll go up 1 to the right 2. I'll make a point. Up 1 to the right 2. I'm at the midpoint. Do it one more time, and we have our slope, meaning I know the perpendicular slope. So if we know the perpendicular slope, we know the midpoint, we can find the perpendicular bisector by just finding an equation of a line that passes through the point -2, 3 and has a slope of -2. Clean up your double negative, y -3 equals -2, x + 2, and distribute and solve. If you distribute and solve, again, you should just be checking your work at this point, so that's why I'm not really going through what I'm doing algebraically here. I'm hoping you get the right answers here. So we have -2x - 1 as your final answer. Hopefully this video helped. If it didn't, or you're confused about something, please reach out to me via email. I'll be happy to answer your questions. Make sure that you're clicking that you completed this on Google Classroom, right? So go through and click I completed the assignment on Google Classroom, and hopefully I see you soon.